Hello and good morning friends, welcome to the CEC-UGC live lecture. Dear friends, as you know that in one of our sessions, in our previous session, we discussed on overview of software engineering. Dear friends, as we told you earlier also that we are going to conduct ample of lectures on software engineering. So today also we are going to talk on software engineering. In our previous session, we left at the point that is we discussed on the quality of the softwares. Today also we are going to discuss some of the left qualities which were left undiscussed in our previous session. We are going to discuss today in this session, that is the qualities of the software, as well as we are going to discuss the development life cycle of softwares. And dear friends, for this discussion we have again with us in our studios Dr. U.S. Pandey. Dr. U.S. Pandey is Associate Professor in Department of Computer Sciences, School of Open Learning, University of Delhi. So dear friends, let's take advantages from Dr. U.S. Pandey and let's try to understand more about software engineering. So without wasting any time, I would like to welcome our guest, Dr. U.S. Pandey. Dr. Pandey, welcome to the EdUcet lecture.
See, we have discussed a lot about the software qualities in the previous session. Now some more qualities related to this software. Another very important quality of a software is reliability. Now reliability is basically a statistical property. Probability that software will operate as expected over a given period of time, inputs, and it is relative in that way how this reliability will take place. It is an important part of any software. Robustness, as you know, reasonable behavior in unforeseen circumstances, subjective, a specified requirement in an issue of correctness, an unspecified requirement is an issue of robustness. Usability, ability of end users to easily use software, extremely subjective. As we have discussed earlier also, these are the few qualities which is very important in software. Now just to define the software qualities, these things are more important, because how a software is going to be easily used by an end user is another important factor. Even if software is very good and you are not able to use it properly, it has no meaning. The qualities of software will totally dependent upon the reliability, robustness, the usability, which is another very important factor for that. Now other software qualities are understandability, ability to developers to easily understand produced artifacts, internal product quality, it is a subjective. As we have just mentioned, understandability is a very important factor. Keep in the mind that if something goes wrong or some kind of changes is required in a software, how these things can be maintained, how these changes can be done. About the internal product quality also, something need to be done so that anybody can easily handle. Anybody means a software engineer or the specialist of that software can do something. Until or unless he understands the software, the product, how these things have been maintained, nobody can do any kind of changes. So for becoming a good software, this understandability quality is must. Verifiability, ease of establishing desired properties performed by formal analysis or testing. Internal quality, this is also an important factor that which keep the performance by formal analysis and testing. how these results are going to be verified, or the programs which you are writing, the codes which you are writing is up to the mark, or it is the up to the mark things which have been used here, it have the established desired properties are being used into the software. The performance, which is a very important factor, again equated with efficiency. Now, the performance of softwares, as you know, sometimes software is very good, but if the performance is not up to the mark, or you are going to get the result in a very late time and it is not up to the mark. So, it is related equated with the efficiency and accessible by the measurement, analysis and simulation, because when you are making any kind of software, the performance is coming onto the top. Whether your software, the result which is going to be produced by this is the good one or not, or which is going to be tested properly or not. So, these kind of parameters are equally important to become a good software. Another soft qualities: evolvability, ability to add or modify functionality, addresses, adaptive and perfective maintenance, problem, evolution of implementation is too easy. Evolution should start at requirements or design. As we have just mentioned, that the software should be like that, that there should be an ability to add something, to modify something. Like if your software is producing at the moment 10 reports, maybe your organization is requiring 25. So, the software should have this kind of facility that if you modify that particular segment, so that it can produce the results required by you or the reports required by you. Some kind of addition is possible, that can be done. So, the different kind of evaluation of implementation should become an easy. In the case of that, it should do the performance properly. In other words, the software must have ability to do a kind of changes requirement by an organization, by an individual, or the programmer which they are required. Reusability. Reusability is also another important factor in the software. Its ability to construct new software for existing prices must be planned for, occurs at all levels, from people to processes, from requirements to code. As we have just mentioned, reusability is another very important factor in a software, good software qualities. Why? Because it's give a way to construct new software. If some kind of changes is required in a particular version of the software, the some segment of software is being used for making a new development, and this kind of facility must be provided in that software. So, in other words, as we have just mentioned, must be planned for, and this kind of facility must be occurs at all level, so that it can meet the requirements properly. So, reusability is also an important factor if the software qualities. Interpretability. The another very important factor is interpretability. Ability of a software subsystem to cooperate with others, easily integratable into larger system. Common techniques include APIs, distributed programming interfaces, CORBA, DCOM, plugin protocol, etc. As you know, to become a good software, this interoperability is very important. If a software systems cooperate with the others, the segments of a software can be used with someone else also and easily integratable to the larger system if required. So, this property is also required to become a good software. Scalability. In the same way, scalability is also an important factor to become a good software. Now, ability to a software system to grow in size while maintaining its properties and qualities assumes maintainability and evolvability. Goal of component based development. As you know, through the scalability, a software can become a good software if it satisfies the parameters of the scalability or the requirement of scalability, where these kind of properties must satisfy. Process principles. Now, as we mentioned, some of the best qualities why a software qualities to become a good software, those kind of things are required. Now, processes principles prescribes all major activities, uses resources within a set of constraints to produce intermediate and final products, may be composed of sub processes. Each activity has entry and exit criteria. As we have just discussed the process principle, how a software processes are going to be used, these principles are must. Like these are any software must use the different subsystem. Take a very simple example, if you are doing a kind of mathematical programming, you are requiring to do the different kind of integration or differentiation or some other related activities. So, each activity must do separately and put together in total. The benefit of that, if some kind of problem persists in a particular segments, no need to disturb the entire software. The particular segment can be checked. In other words, if some problem persists in a particular segment in one area, they need not to go to the look into the entire software or to disturb the other services. So, to become a good software, this process principle must be adopted. Not only that, in every places there must be a facility of entry and exit also. If some process is completed, no need to go through other routes. There should be a facility to take it out from there or exit from there. If a particular software which have been developed for a large number of activity and some users want to do only one small activity, he must be given a facility to use that software, or in other words use that particular segment only, and after utilizing that software he can exit from there easily. So, there are lot of other process principles are there which need to be followed for developing a good software. Activities are organized in a sequence, has a set of guiding principle to explain goal. Constraints may apply to activity, resource or product. As we have just mentioned, it should be, or the programming or the activity should be in a sequence, not in a haphazard way. If everything should be in a order, and as we mentioned that the guiding principle to explain the goals also, if some kind of activity is taking place, it need to satisfy what kind of principles you are applying, what kind of formula you are utilizing, and what is the main benefits of utilizing that, the significance of using that kind of technique, each and everything must be satisfied. Not only this, if we are using a particular technique to solve a problem, that method should also be discussed properly, why we are going to use that particular method. Not only this, what is the reliability of that particular method you are going to use. Take a very simple example, if you are using a different kind of searching or sorting techniques, which technique we are going to use and why, these needs must be defined properly. Which kind of technique for any kind of statistical purpose, for any kind of mathematical purpose, for any kind of financial activity, anything you are using, why you are going to use that one. What is the performance, reliability of all those kind of, these needs to be tested and need to be defined, why we are going to use all these things here. Because these things are also coming into the process of principle. As we have mentioned, things should be in a order. If you are doing, it should be step by step defined properly. Constraint may apply also to the resource or the product also. Another, as we have just mentioned, the guiding principle to the explained goals. Software development stages. We have just discussed about the software qualities, we have discussed about the process principles. Now, software development stages, one is requirement analysis and specification. As you already know, when you are going to develop a particular software, you need to see the requirements, do the detailed analysis and find out the specification requirements in each everything. Another very important thing in this software development stage is conceptual system architectural design. The which kind of design is going to be preferred for that, what kind of software is going to be used, which kind of architecture is going to be used, each and everything need to be defined at initial stage. Not only this, as we have just mentioned, based on the requirement, based on the analysis and the specification and the needs of that organization, you have to choose which kind of software you are going to use, what kind of architecture you are going to follow. For example, if a very small organization you are going to use, then the software which you are just going to use for developing a system, it is not to be very costly. But if an organization is big, definitely you are going for a big software changes, big system design. Like already you know, there are big organizations which are using ERP, SAP and many other kind of activity, but the same kind of system can't be fitted in a small organization. So, total dependent on your requirements, the specification, the needs of your organization, based on that you have to develop the system design, how this kind of design is going to be maintained. Then the detailed program, based on your system design, based on the requirement, the architecture you have designed, define the same way you have to develop the programs. After developing the programs, now another important factor is implementation. In an organization, after writing all the programs, after developing the whole system, now implementation is another very important factor. Here each coding and everything should be done properly. Then another and last stage is unit and integration testing. As we mentioned in the software, this last phase is very important, unit and integration testing. What happens? As you know, when the different stages, the software is ready, it is being implemented in an organization. Before that, it is very important to get it tested properly after implementation, whether the software is going to meet your all requirements or not, the proper or not. What is happening? Sometimes theoretically many things are valid, but when you do those things practically, it may create a problem. For example, take a software which is running very fine, but the same software when it is being used to the 200 or 300 or more computers, maybe you are not getting that kind of performance is required. Already you know, take a very simple example, you know about the railway reservation system or for reason any reservation system. Time to time they used to get it modified by utilizing making some kind of changes into the system. Earlier, the same system which was running fine may have some problem, not able to book the ticket, too much tickets in time. But now you do have a facility, some kind of integration have been done, testing have been done, and after that some changes have been incorporated in the same software, and now the same software can book as many as tickets in a limited time. Not only this, you may be knowing that time to time the same railway reservation system, they make changes in a Tatkal system or in a different system also. Sometimes even in the development, these softwares are not playing the exact role what require. For example, some kind of different softwares which are not responding properly. Now the time and other things required, and this implementation, coding and integration testing doing done, you can make the changes accordingly. Another very important, as we have mentioned, the system testing and validation. As we just mentioned, system testing is a very important factor of this development stage. What is happening is the same example, if you are able to do the activity very much in time, whether the performance is up to the mark or not, these kind of testing and validation is very much required. Not only this, whether the system is working in the wrong conditions also, or is it providing the help to the users if required. If you give some wrong information to the system, how it is responding. These all, not only, there are many other factors need to be tested for the system also. Maybe you are knowing, take example of online banking. Banks give lot of money to the hackers also just to check whether the system is running fine or not. They are doing the hacking just to check the ethical hacking, or if some person can do some kind of changes into the environment and do some wrong activity. Same way, all the softwares need to be tested and properly validated whether in other conditions also they are running fine or not. So, the system testing and validation is a very important factor in the case of system development stages. Another very important factor, again, system delivery and deployment. After doing all kind of implementation, system testing, and after validating the software, the system is going to be delivered, or in other way, it is going to be finally deployed to the organization. After deployment, as we have just mentioned, clearing with all stages, these systems are going to be implemented properly, or in other way you can call deployment properly. Maybe you are knowing, sometimes a different versions of software is released just to check whether any kind of bugs are there, any kind of problem is going to be faced by this, and after all this system is going to be delivered and deployed properly to the organization or the individual needs. The maintenance, which is a very important factor of any software development stages. Note, there are many variations on the names. You are responsible for the main categories above. On the next page also, like different kind of software life cycle models are there. As we have just mentioned, the different kind of testing techniques are there by which you can check whether these things are a valid software or not. To begin with, a waterfall model, V model, phased development model, incremental model, prototype model and spiral model. Software development life cycle waterfall model. Now see, as we have mentioned, there are different kind of development life cycle models are going to be there: requirements, design, implementation, integration, validation and deployment. As we have just mentioned, these are the different life cycle models are going to be there. You have to assess the requirements. Based on the requirements, you have to develop the architecture and design the software. After that, you have to implement the software. If something changes are required or any other kind of activity is going to be there, that will come into the integration, and after doing the proper validation, the software is going to be deployed. And even then, after that, a maintenance, which is an important factor, that is going to be used, because developing a software or only up to the stage of deployment is not important until or unless it is properly maintained. Due to some problem, if some kind of errors are occurring, that will be covered into the maintenance, or some kind of other requirement exists, that will be also addressed by the maintenance. So, that is also a very important factor into that. Here you can see how the after requirement, design, implementation, integration and validation deployment is going to be done. Now, in the requirement phase itself, you can see here that how the requirements, plan, schedule and design after replan and reschedule can be done if required. After doing this integration and validation, this requirement, you can check that it could be possible that even after deployment, some kind of problem is persisting. It could not be a problem, you need some kind of more specification, your requirement is going to be little bit more different after developing a software. Then you have to do rethinking about that, and if required, minor changes is going to be done into that. You can see here that these kind of changes are going to be addressed into this model. Another model is V model. Now, here in this model you can see as the same requirements analysis that have been done, system design. As you know, after system design, this program design and coding, each and everything have been done. The unit and integration testing have been performed properly. System testing have been there. Accepting testing have been done, and operational and maintenance activities there. But as we mentioned, if we require some kind of activity, some kind of problem, requirements or some kind of changes is going to be there at accepting system again it will go to the requirements analysis and do the needful changes at if some kind of change is required in system designing or some codes to be added or something need to be modify, these things can be addressed properly. So, this is another model by which the things can be developed properly. So, there you have gone through the water model as well as the V model. Now, another model is phased development model. Here you can see the developers and the users. The development systems build release 1, release 2, release 3, and on the basis of the user's requirement uses release 1 and release 2 and release 3 also. So, here this is another going to be the production section system into that one. So, this is how the phase development model is going to be there. You have done some kind of releases, as you know that sometimes big software industries including Windows and also they come with a different version at one time, and if need to be seeing the capabilities and the things of the users, the requirements of users, they make the changes. As maybe you are knowing from the Windows 1, 2, 3 up to this stage, lot of versions have been released till now. Windows 10 is in the market, seeing the lot of creative activity of the users or the demand of the users, see the activities of the users, they notice each and everything and simultaneously make the changes, upgradation or the other developmental activity into the software, and they come with the new release. It is the production system and they make the changes into the system, come with the new release into this one. Another software development life cycle, that is incremental model. You can see here that the version 1 complete general design, as we have just given the requirements, design, implementation, integration, validation and deployment. These are the basic things which is required in the total life cycle of a software development, the complete general design. Now, what will happen into the version 2? The design, implement first set of a planned new features. Note, overlap with the complete general design of the version 1 schedule. What will happen into the third version? Design, implement second set of planned new features. As we have just mentioned that when a new release are coming, new version is coming, then usually the other things will remain unchanged. First they will give you the new categories, the new ideas what you have that plan, or in other words the new features which have been given to the new version. The revised the software which you are going to use, the another new features which have been implemented that have been shown, and after that there is a facility that even you can integrate that software also. In other words, if you are utilizing something in a lower version, they must have this kind of facility that can take up to your larger version also or the latest version which have been released. In other words, they give you the new features in the beginning itself, so that you may be knowing what are the additional features which have been added to the new version software. As you know, in the beginning lot of many versions of different softwares are coming. For a take example for a Oracle, every time they may added something, they give a new features and simultaneously they are utilizing their old activity also. So, they built it upon that, basic platforms remain sometimes unchanged, they develop some kind of new module, they develop some kind of additional features, and beside that they provide you all kind of upgradation and other activities also. Sometimes if the entire software is not changed, they give the kind of facility so that even the work which you have completed into the previous version is not going to be harmed in any way. Another prototype model, another model is prototype model. Listen to customer, build, revise mockup, customer test drive markup. Now, this is another type of model by which a system development life cycle things can be done. Then you revise the activity, the develop each and everything like that, and this customer test the features which have been built into that, and then it has completed, and after listening to the customer they make it required change. So, this is another prototype of model. Maybe you are knowing there are thousands type of software are there, but sometimes it is not like that all the software are very much popular. It means there is some region, means the some softwares are liked by the customers, some of them are not. Some of the softwares are properly accepted by the organizations, some of them are not. It will be totally dependent upon the customers, the requirements, the needs of the organization, or to the users, how they are taking that software is. Already maybe you are knowing there are many operating systems are there in the market. Some people like one software, some of them liking others. But how the users are responding to that particular activity, that is more important. Take example again, for example, you know that MS Office is very popular. Why? Because it is providing a very easy facility to the users. They have lot of components developed in their software packages. You can do the typing using MS Word, you can use a spreadsheet, you can make different kind of graphs, different kind of presentations and all, maybe by using MS Excel or this PPT presentation program. Not only this, you have a different kind of activities which can be performed easily by using this MS Office. Does not mean there are many other software are also available into the market, but it is not very popular amongst us. See, this is the usability of these kind of softwares. Some of the operating system, people prefer many Windows, some of them are using other operating system. So, it depends how the customer like it, how the users like it, or what is the organizational needs. Sometimes these kind of softwares are good for a small organization or any individual, but it may not able to satisfy the objective of a bigger organization. So, they need something different. So, as we mentioned, these kind of different model address each and every activity in this regard also. In the same prototype model, you can see here the list of revisions, revise prototype, if required, user customer review, list of revisions, prototype design, prototype system and test, and as we have mentioned, after system requirement, sometimes informal or incomplete in the last delivered system. So, in this model also, after going through all, if required, the changes are going to be done into the system or into the designing, prototype designing and prototype system, doing after testing, and you can deliver the system. Spiral development. Now, another type of development, processes is represented as a spiral rather than as a sequence of activities with backtracking. Each loop in the spiral represents a phase in the process. So, this is another way of doing the kind of development where each loop in a spiral represent one phase in that particular processes. So, that processes are developed using different phases, that phases are going to be developed named as the spiral development. In the spiral development, no fixed phases such as a specification or design loops in the spiral are chosen depending on what is required. Risks are explicitly assessed and resolved throughout the processes. So, in the spiral development, this is also an important, the risks are explicitly assessed and resolved through the processes. You can see here the spiral model of a software process, where different kind of activities are taking place, different kind of things, how the preview, repair require the amendments plan, life cycle plan, risk analysis, prototype one, conceptual things, and in the simultaneously you can see the different prototypes and risk analysis and how the plan last phases are going to be there, which is services, adaptive test, implementation, integration, unit test, code and detailed designed are being modeled into this spiral model of different software. You can do it as requirement validations and each and everything. So, here you can see the spiral model of a software process. Another thing is in the spiral model is objective setting. A specific objectives for the phase are identified. When you are going for a spiral model, it is important that the specific objective that for that phase need to be identified. Risk assessment and reduction. Risks are assessed and activities put in place to reduce the key risk. As we have just shown you into that model, that different places we have used that key risks, because putting that it will reduce the risks are going to be there. And that something more is going to be there in the spiral model is development and validation. A development model for the system is chosen which can be any of the generic model. Planning, the project is reviewed and the next phase of the spiral is planned. As we just mentioned, in the model itself we have shown you the different planning which is going to be there. The project is reviewed and the next final of spiral is planned accordingly. In the software design and implementation, now you know about the different kind of models we have discussed: waterfall model, V model, incremental model and spiral model and all those. In the C, here in the software design and implementation, which is very important factor into that one, software engineering. The process of converting the system specification into an executable system. Software design, design a software structure that realizes the specification. Software design and implementation, as we have mentioned earlier also, is an important stage basically in developing of a software. As we have just mentioned, the objective of software design is to meet the goal, the requirements of your system. You have to develop system in such a way that, as we have just used a word, executable. The process which you are going to use, the methodologies which you are going to use should meet the requirement of the organization, or the what is going to be the needed by the organization or particular office or particular individuals needs to be fulfilled. Software design and implementation, in implementation, as we have mentioned, is very important in the sense that it translates this structure into executable program. The activities of design and implementation are closely related and may be interleaved. As we have mentioned earlier also, that designing and implementations are very closely related, because you have to design things properly according to the needs or the requirements, and this needs to be implemented properly. Design process activities, architectural design, abstract specification, interface design. As we have discussed about the software design and implementation, the designing process activities are architectural, abstract and interface specific thing. Why this thing is going to be there like that? We have just mentioned that these things are entirely depend upon the requirement or the needs of an organization or the individual, or what purpose these softwares are going to be developed. For example, if a particular software is going to be used by the individuals or human being individually, then the architectural design is going to be entirely different if the software is going to be used only for an official purpose or in a particular organization for a specific purpose. Because in every case activities are going to be different. Take a very simple example. A lot of activities related Aadhaar card, PAN card are different kind of cards which is being used by individually also, and organizational needs are also going to be there. So, to execute each and everything properly, so that an individual can receive information properly, handle properly, he can see the details properly, is entirely different that if we are doing some kind of development in an organization for a particular kind of calculation. It could be a different kind of calculation, preparation of a budget for an organization, preparation of a bill for an organization is entirely different, because both of them have totally different segments. So, depending on that, you need to develop an architecture, which kind of architecture is suitable for developing a software where you are going to be there like. So, that is why in designing process the activities are very important. In the same way, the abstract specification must be clear how the things are going to meet the goals and all, and same way interface designing is also need to be done so that it can meet to the objectives. In the design process activities, some of the more components which are very important, one is component design. As we have just mentioned, according to the needs of organization, according to the needs of the system and other activities, you have to do the component design also. what are the different segments being there in that particular organizational activities that need to be defined separately. The data sectors need to be designed properly, which data structure is going to be the most suitable for that kind of activity. As we have just mentioned now, different kind of activities are going to be there, different kind of needs of an organization is there. Maybe some organization need entirely different activity than a different organization. So, based on that, which data structure is going to be the most suitable for those activity that need to be addressed, and in the based on that you have to do the algorithm design. Sometimes getting result is not only important, sometimes how you are going to get that result is also important. Timely how you are going to get the result, what is the best suitable algorithm is need to be used, that also need to be addressed. So, that entire in the designing process, this component, the data structure which is going to be used, the algorithm which is going to be used is also an important thing, so that you can meet your objective properly, you can address the activities, the requirements properly, and it should be a reliable activity. The meaning is getting, as we have mentioned, getting result is not the only thing. The entire thing is that how much correctly you are going to get the result by using a right path, correct method, or the approved method, reliable methods which are going to be there, the methods which are efficient, up to the mark, approved, these need to be addressed, and this kind of activity to be done. The software design process, here you can see the software design process, requirement specification, architectural design, abstract specification, system architecture, software specification, interface design, component design as we have just mentioned, and data structure design, algorithm design, the interface specification, the component specification, data structure specification, and algorithms specification. Here you can see design activities as well as design products also. So, after doing all these things, you will be in a position to develop the system architecture, system specification, interface specification, component specification, data structure specification, and algorithms specification. You can see here how the software design process is going to be into the complete way. So, the process designing of a software utilizing all these kind of component, you can do it in that way. Architectural versus you can see called design. The architecture is a concern with the selection of architectural elements, their interactions, and the constraints on those elements and their interactions necessary to provide a framework in which to satisfy the requirements and serve as a basis for the design. So, as we have just mentioned, these things are entirely depend upon the requirements and each of the organizational activity. The Perry and Wolf in 1992 has given design is concerned with the modularization and the detailed interfaces of design elements, their algorithms and procedures, and the data types needed to support the architecture and to satisfy the requirement. So, this is how the architecture and the design have been given by these scientists. Requirements and specifications of an architecture and design. You know, architecture decomposes software into modules, objects, components with interfaces, and design develop module, object, component specifications like algorithms and data types and communication details. It maintained a record of design decisions and traceability. It specifies how the software product is to be its task. So, that is going to be there for different kind of activities which we have discussed today. Thank you.
With this note, thank you sir, thank you so very much for giving a productive session on software engineering. Dear friends, as we have told you earlier also that we would be conducting more sessions on the software engineering, and through these sessions we are going to learn the different aspects of software engineering. And dear friends, if you have any queries or if you want to give your feedback regarding this particular lecture, then you can mail us at info.cec@nic.in. and if you want to access this lecture once again, that is if you want to see this lecture a number of times you wanted, then very soon we are going to upload this lecture on YouTube, with the help of which you can understand and you can grab the knowledge with the help of those lectures on the YouTube. We would be meeting again very soon. Till then, take care. Goodbye. Thank you sir. Thank you so very much.